The aim of this experiment is to determine the coefficient of friction between the glass and the wood. Okay. Now, the apparatus which is required to find experimentally the coefficient of limiting static friction between the glass and wood is number one, a horizontal plane surface, this one, with the glass top. Okay. And you're looking a scale, vertical scale, this one, it is fitted to determine the height of the inclined plane, right? Now you can adjust any angle, okay? You can adjust any angle of the inclined plane with this baseline, with the help of this screw. We are looking here, the angle is 10, 10, 20, and then here is the 30. So you can have any value of the angle, but remember the angle is made by the glass surface, not the wooden. This glass surface, the angle made by this glass surface with the baseline. So this is around 29 degree. Okay, this angle is 29 degree. So any angle can be adjusted. Now the angle is made 0 so that the surface is exactly plane. At one end, there is a frictionless pulley. Now this is weight box. We are having different weights. Now this is a wooden tray, right? And there's a spring balance, and weight of the pan, it is 17 gram. Okay, we noted down, weight of the pan is 17 gram. Weight of the wooden tray, 123 gram. With the help of the spring balance. Weight of the roller, 343 gram. The thread is passing over the pulley, and then at its another end, a pan is attached here. So what we do, we put some weight in the pan, starting from the very minimum value of the weight, like 5 gram is added. Then we tap gently so as to see whether the wooden tray is sliding or not. Not sliding. Then we put another weight, and then we add another weight, 2 gram. Again tap gently, and then looking, and look, is it sliding or not? So go on adding the weight by starting from the lowest value until you will reach at some particular weight. Then when you tap it, just sliding. It's like just sliding starts, look. Just sliding starts. So when the just sliding starts, what happened? Weight of the pan plus weight in the pan. Weight is, the unit of weight is gram force or dyne or the Newton. Okay. And the mass which we put, that is 19 gram, and weight of the mass of the pan was 17 gram. Then 17 multiplied by g, that becomes the gram force. Similarly, 19 multiplied by the g is acceleration due to gravity. That becomes the, gram force. Now this is gram force, not gram. This is gram force. So total becomes 36 into g, gram force. This is the weight of the pan. Now what is the weight of the tray? One mass of the tray was 123 gram. Then multiplied by acceleration due to gravity, it becomes, gram force. Okay. And weight of the tray is what the normal reaction. How? Like if this is, the body, this is the horizontal surface, it's the weight is mg. Now the weight is balanced by the normal reaction given by the horizontal plane surface. Horizontal plane surface giving a reaction R. So R is exactly balanced by mg. So now if you are applying the pull along this side, this is applying pull, and pull is so adjusted, we are increasing pull starting from the lowest value till the body just starts sliding. In that case, there will be friction between the body and the horizontal surface, and that friction will be the limiting static friction, FL, and it is better to put S also. FLS means limiting static friction, because the body is just sliding. Before sliding, the friction will be the static. Just sliding, friction will be the limiting static. And when the body will be in motion, then friction will be the kinetic. But in our case, the friction is the state of the body just sliding. The friction is the limiting static. So how much the limiting static? Equals to the pull, because this body is just in a equilibrium. So whatever the weight of the pan plus weight in the pan, that means pull, that becomes the limiting static friction, F. And what is R? Equals to the weight of the tray, which is 123 into g. Now we find coefficient of limiting friction, which is F upon R. So dividing F by R, 36 by 123. G and G cancels out from numerator and denominator. And coefficient of limiting friction becomes only just 0.29. And there is no unit of coefficient of limiting friction, because units cancels out from numerator and denominator. Okay, just see the weight. Mean the force of attraction between the two surfaces, that is, the force of friction, is always proportional to the normal reaction. Right? Now we are coming, what is the angle of repose? Now what we are doing, this is the inclined plane, right? Now the body is placed over the plane in wooden tray. Now there is no thread, okay? And there is no thread and no pan. There is just a body wooden tray over the plane. Now what we do, now we'll go on increasing this angle, starting from the very low value. And then, now just looking here, and then when we increase the angle, we just tap gently on the horizontal plane so as to see whether it comes just in sliding or not. So we go on tapping. So we reach our angle. So just increasing and this is that angle. This is at that angle where the body is just sliding in a position of the just sliding. So this angle is then called angle of repose. So it is defined as minimum angle made by inclined plane with horizontal. So the object placed on the inclined plane just begins to slide. So we note down what is this angle. We note down now we fix this angle with the help of screw. And we see what is this angle. So this angle is the glass surface is, this glass top is in between 16 and 17. That means this angle is theta, which is equals to 16.5. So this is what angle of repose, 16.5 degree. This is 6, okay, 16.5 degree. Now what happened when the body is placed over here, right? Then the weight will be perpendicular to this ground level. So I show the weight like this. This is the weight, and weight equals to mg. And the reaction will be perpendicular. The reaction will be perpendicular to what? This glass surface. This is R, right? Then mg is resolved into components. How? Mg is resolved into components. Okay. Mg is resolved into components. If this is angle theta, you notice this will be also theta. This will be also theta. So this component will be mg cos theta, and this component will be mg sin theta. Mg sin theta. So mg sin theta will try to pull the body down. So when there is a tendency of a body for coming down, so what happens? The frictions comes into play. And if the body is just in equilibrium, that means just sliding, then mg sin theta will be balanced by the force of limiting static friction, because just to move, that means the equilibrium is there, the last equilibrium, after which the body will start moving. Okay, but when the body just in sliding, mg sin theta will be balanced by FL. So mg sine theta mg sine theta, okay, mg sine theta is equals to what? Friction, and mg cos theta is balanced by, tell me, mg cos theta balanced by the normal reaction R. So mg and mg cancels out. Sin theta or cos theta becomes tangent theta. So tan theta equals to what is F upon R? Okay, tell me please, what is F upon R? This is coefficient of limiting static friction. So what we find just now, this angle is 16.5. So tan of 16.5 should be equals to, tangent of 16.5 should be equals to mu. And you just find out the tan 16.5, and why sure it will come out, it will come out very close to 0.29, because previously we found the value of mu, right, equals to 0.29. So I'm sure tan 16.5, if you look in the table or from the calculator, you'll find tan 16.5 very close to 0.29. Okay. Now we are coming how we find the coefficient of rolling friction. So this is a weight roller. Now roller will come down because this is an inclined plane and angle is somewhat greater than angle of repose. So the roller will come down automatically. Now you go on adding the weight in the pan till it balances with Go on adding the weight in the pan here. Go on adding the weight in the pan. We have to just stop the roller from its rolling state, you can say. So go on increasing the weight. Now we just reach at some particular value. We reached some particular value when there is no roll, when there is no rolling. On adding the weight till the roller, we have to stop the roller from rolling. Just stop it from rolling. Go on adding the weight. Go on adding the weight till we stop it from the rolling position. Now weight of the pan plus weight in the pan, when we stop it from rolling, then it is 17 plus 17. This is mass multiplied by G becomes the gram force. Weight of the roller 343 gram multiplied by G becomes the gram force. Now coefficient of rolling friction. Friction is the opposing force that is set up between the surfaces of contact when one body slides or tends to slide, or when one body rolls or tends to roll on the surface of the another body, right?